From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. This episode of Fragmented has been brought to you by Rollbar. With Rollbar, you can catch code errors before your users do, because I don't know about you, but the last place I want to find an error is inside of a 1-star review on Google Play. That's just pretty much the worst case scenario, because getting those 1-star reviews to go away is really problematic. So the next best thing is actually preventing them from happening. So if we can prevent those errors, even better. Rollbar will help you do that. The cool thing about Rollbar is they work with all your existing major languages and frameworks. And to really tie this together is they work with your Android application, so they're bug and crash reporting, all that kind of stuff. And they can also do this on the server as well. And then you can tie that together. So knowing this release X of the Android app and release Y of your Rails API, this perfect storm is happening and you're getting these errors. It's easy to track those things, much easier than it would traditionally be if you didn't have a solution like Rollbar. The cool thing is they also integrate with existing things like Slack. So when I do a deployment or have an issue that comes in, it automatically notifies me inside of a Slack channel, which makes it really easy for me to see what's going on. Especially if there's something that's really high priority, I'll know immediately because I'll be getting a bunch of alerts and it's time to go fix it and check it out. Rollbar is used by a bunch of companies. Kaushik uses them, I use them, but there's also folks like Heroku, Twilio, Kayak, Zendesk, Twitch. The list goes really on and on and on. Now, if you'd like to check out Rollbar, you can go to rollbar.com/fragmented and you'll get the Bootstrap plan for free. Again, go ahead and check that out at rollbar.com/fragmented and you'll get that Bootstrap plan for free. Thanks for listening and thanks, Rollbar.
In this episode, we continue with our Learning Kotlin mini fragment series. Kotlin now has first-party support from Google and is a beautiful language, so we want to jump right on that train and learn it as well as we know Java. In this second episode, I talk about Kotlin's support for static members, or lack thereof. Kotlin as a language was designed so that there's actually no such thing called a static member in a class. But there are times when having static members can be pretty useful. So what do we do in those cases? Do we just avoid static members? Are there better alternatives? What are the costs with some of these approaches? Listen on to find out more in this episode. Okay, so when I started out learning Kotlin, one of the things that really struck me was the fact that Kotlin as a language was designed so that there's actually no such thing as a truly static member, so to speak. Classes in Kotlin can't have static members. In fact, the Java static keyword doesn't even exist as part of the Kotlin language. Now, people generally poo-poo on static members for the most part, and they do this for multiple reasons, right? It boils down to global state. Static members basically are like global state holders, so it's hard to reason about the changes happening on them. Along the same lines, they aren't also as tightly scoped, so inherently they're hard to test. If you're into mocking and stubbing for your test, then mocking static members is kind of hard unless you use like some special libraries. Static members once created typically last for the lifetime of your application, which can both be a good thing or a bad thing until they're destroyed or collected. So all this are sort of the disadvantages for static members. But this being said, there are some times when having static members can actually be useful, and it makes perfect sense to have static members. Let me give you some examples. Constants. In Java, the public or private static final fields are basically how you create constants in Java, right? And there's a perfectly valid case. For example, in Android applications, we have tags, and that's a perfectly valid case. Like instead of having these magic constants or magic numbers, which is kind of an anti-pattern, then you want to create specific constants that sort of add more context to these values that you have, right? So there's definitely a place for having constants as static members. The other big use case where we want to be able to use static methods is for factories and factory methods. Again, this is like a perfectly legitimate case. I'm not going to go into the details as to what the factory pattern is in this episode, but look it up. Definitely a completely valid case where you would need the use of static members. And lastly, there's one mildly controversial but also sort of useful one, Singleton Patterns, right? Before enums, one of the most common ways to create singleton classes in Java was using, storing the instance, that single instance, as a static final variable inside the class, right? So again, this, if you're into using the singleton pattern, perfectly valid case. But Kotlin doesn't even have the static keyword. So what do you do? Can you not have these use cases? Well, what do you do when you have Java code that you want to know how to make work in Kotlin? You open up IntelliJ, you copy that Java code, you paste it in, and you see the output Kotlin code that's generated, right? Now, if you've already done this, you'll notice that almost always the converter will make this thing called a companion object. What is a companion object? I'm going to tell you in a minute. But honestly, I feel the true alternative that not too many people seem to realize exist, or like they don't talk about it as much as companion objects, is package level functions or package level variables. This, again, in my humble opinion, is the killer replacement that is almost always the option you want to pick. Now, obviously, it's never that simple. And also a gentle reminder, I'm new to Kotlin as well. I'm learning with you. So if I'm being a little crazy, shout out to me on Twitter or the comments so I can actually learn as well and correct this. But there are times when you can't use package level functions or members. And in those cases, companion objects are the way to go. But what I want to do now is to actually take you through my thought process or my journey in understanding all of this. When, like, for example, when to use package level functions or variables, where they don't work, when to use companion objects, where those don't work, what's the cost of each of these options, etc. So let's start with that. Firstly, package level functions or members. This, again, is what I feel you should almost always try to use if you can. What are they? I'll drop a link in the show notes to the docs, so always keep an eye out on the show notes for useful links. Basically, you can take a Kotlin file. Notice I'm saying here a file and not a class. Open up that Kotlin file, with the KT extension. You can declare a package name right up top. Again, it's not mandatory, but obviously good practice to do it. And you can just plop a function or a method directly there. It doesn't have to be nested inside a class. You don't actually have to create a class or object in that Kotlin file. You can also drop variables, so vals or vars in there, and they can exist as package level variables. Let me actually read you an excerpt that I thought was very interesting from a blog post that JetBrains has up. If you need something that is not attached to an instance of any class, you define it in a package outside any class, and we call these package level functions. And what is something that is not exactly attached to an instance of any class? If you think about it a little harder, I mean, that's kind of what static members are, right? Like to some extent. These are also called top level declarations, right? So if you just have this function or like this variable directly dangling without being nested inside a class in Kotlin, these are called package level functions or members or top level declarations. I say this because sometimes when you look at the Kotlin docs, they actually refer to these as top level declarations. Now, an aside, Kotlin compiles down to Java under the hood, right? So there's actually no magic here. It's not like somehow magically Kotlin allows you to not have a class file and like it just sort of like exists in the ether, right? Like there's no magic. If you open up the compiled down class for package level functions or members, what you'll actually notice is internally Kotlin generates a final class with the name of the Kotlin file. So say I had a Kotlin file named myuser. Internally, it creates a final class called myuserkt, right? And inside that final class myuserkt, you'll find your package level function as a static final method. So under the hood, it's exactly as you would want for like your static calls. So if package level functions are like the bomb, why even have companion objects, right? And in fact, you'll notice IntelliJ is pretty aggressive about using companion objects most of the times when you do like your auto file convert. Well, let's look at some of the limitations of package level members, right? There are two sort of major limitations in my mind. Namespace restrictions is kind of a limitation, but not really. There's a way to work around it. What's the other limitation with package level functions or members? Well, the big one, and this is kind of like the more important one, private member access. Now, when you use a package level function, you obviously aren't nesting it inside the class, which basically means then you don't have access to any of the private members of an accompanying class, right? So say you have like a regular example for a class file and you want to create a static method to that class file, but you're like, hey, Kaushik told me like package level functions make sense. So instead of putting it directly in that class, you move it up and put it at the package level for that same file, right? What will happen is that package level function won't have access to any of the private members in that accompanying class. Now you may think, well, when would I ever need this? Why would I ever need private member access to those inside my static member method, right? Well, factory methods. That's when you need it. Now, when you use a factory method, typically you perform like a lot of initializations to that object, which can be kind of complex, right? Like that's the whole point of that's where you can leverage the power of like the factory pattern, right? You have these complex initializations and you don't want the API consumer to necessarily have to deal with a lot of these things. So you push that all into the consumption point, right? You create this nice factory method with a pretty API, and you do all the complexities like placed within that factory method creation, right? And in order to do the initialization, it's pretty common. Like the factory method often needs a lot of access to like the internals of the class, right? Like that you don't want to otherwise expose. Just because you need it for the construction of the factory, that doesn't necessarily mean that you have to expose these as public sort of members, right? And this is going more into like the fundamentals of the factory pattern. And in Java, private level encapsulation in Java is basically for the file level, right? So if you have that static method inside the same Java class file, it doesn't matter. Like you have access to the private members, which is why it's pretty useful in the factory pattern, right? It just makes being able to access the private members directly in your static factory methods makes life much more easier. But let's step back now. So stepping back into Kotlin land, package level functions don't give you access to those private members of the class because they aren't even nested in the class, which basically means you cannot use package level functions more often than not for factory methods, right? Like, or it becomes really hard unless you don't need access to the private members. So to solve this problem, Kotlin has the concept of companion objects. And this is where we get into this whole concept, right? Like anything you put inside the companion object for all practical purposes basically becomes static. And inside the companion object, I do have access to the other private members. I mean, really, this says that there's only ever one instance of this companion object for that class, and this holds like your method. But what I want to do now is I want to actually take a step even further back and dive into the fundamentals of what Kotlin calls as a basic object, right? Like the object keyword in general. And then we'll try to work our way up to like a companion object. Now, the Kotlin in Action book that I referred to in previous episodes actually has one of the best summaries for objects and companion objects and like how all of those, how those have created. So I'll try to highlight some of the main points that I picked up from that. Objects essentially come in 3 different varieties in Kotlin, right? But there's just one fundamental core idea with all of them. Anytime you use the object keyword, you're automatically defining a class and creating an instance of that class at the same time. This is actually kind of important to realize, especially when we start to evaluate like the cost of using these objects, right? So I'll repeat this again. Anytime you use the object keyword, you are automatically defining a class and creating an instance of that class at the same time, right? Basically, if you think about it, what it's doing is it's creating a singleton, right? Like that's the easy way to think about it. Because if you define the class and it gets instantiated, but you can't create any more instances of that class because when you create the object, there's no constructor here, right? So there's no question of creating this again. But as you define it as an object, it's creating an instance of that class. It's kind of the singleton pattern, right? So keep that in mind. In fact, this is not like a byproduct of like different decisions. This is very intentional. Kotlin wanted to provide first-class language support because they found it to be pretty important, right? So if you have to create singletons, the easiest way to do that in Kotlin is basically just slapping on the object keyword. Now, if you remember in Java land, creating proper singletons, and I'm saying proper in quotes, actually requires a lot of hoop jumping, right? Like, there's like enums, which is like the recommended way now, but there was also like holding it in private static members. Listen to a previous effective Java episode to get, all the details on that. Okay. So there's another variety of using the object keyword, but this is when you actually use it as an expression. When you use the object keyword as an expression, it basically doubles up and acts as what we call in Java an anonymous inner class. I'm just laying this out there. I actually have, again, another episode that I'm thinking of doing just to deal with what Kotlin calls expressions, because I think it is actually a powerful and beautiful thing. Again, but different episode. It's a beast of its own. I don't want to deal with that now. Just keep in mind that that's the second usage of an object keyword. Like you can basically create anonymous inner classes using the object keyword. So that's the second variety. The final and the most important one that for our episode today of using the object keyword is with this qualifier called a companion. So a companion object. And this is where like our whole story began in the first place, right? Okay, so a companion object uses the object keyword. So still, there's only a single instance of this being created and the class is defined and the instance is created. But what does adding the companion keyword, like how does qualifying this object with this companion keyword make it any different? Well, it's actually kind of very similar to creating a regular object, right? And in fact, this is like a common question that most people ask when, we're learning Kotlin. What's the difference between just using a regular object inside a class and a companion object inside a class? But from what I gather, there's like a couple of differences, and I'll go through them. First, it's sort of a semantic distinction, right? So when I say companion object inside a class, it's basically an idiomatic way of saying, hey, everything inside here is basically shared for this class. It's where I would put what I otherwise would consider my static members in Java, right? So this is basically where it all started. If you truly need static members in Kotlin and package level members won't cut it, use companion objects, right? So anything inside this companion object essentially serves as like your static members. There's other differences between objects and companion objects. You totally could still use a regular object inside a Kotlin class, but companion objects can only be placed inside a Kotlin class, not at the package level. Because, again, that would need a companion, so to speak, right? If you're saying it's a companion object, like it needs a companion. It just can't stand alone, right? Objects, on the other hand, you can just open up a Kotlin file and just plop an object there, and that functions as a singleton, right? So again, that's like it's kind of obvious if you think about it, but that's the second difference between a regular object and a companion object. Companion objects need to be nested inside a class because they need a companion. Also, a side note, almost always you probably don't want to be using a regular object inside a class. Again, this is from my usage and the little that I've read online. They say usually if you're doing that, there's a better alternative to what you're doing, right? There's very, very few cases where a regular object nested inside a Kotlin class makes sense. So that was the second difference. And now the last difference is actually a subtle one. And this is more for your knowledge, not necessarily related directly to like the static-ness, right? It's kind of subtle. And that it goes, and the difference is around the initialization order, right? Between a regular object and a companion object. Companion objects are initialized from the static constructor of the containing class. So if you have like your companion object nested inside a class, whenever like the constructor of the parent class is called, or like, whenever that class is instantiated, automatically the companion object is also initialized with the parent class. However, with plain objects, they are actually initialized in a lazy fashion because they're not necessarily associated with the companion. The first time they're actually initialized is when your program requires access to that object. So it's a little subtle. So it's almost like a lazy sort of initialization that you have with regular objects. So far, like we've been talking about like some of these good concepts. I'm going to talk about the final section now, which is kind of the one that got me started thinking about all of this. And that's like the cost of using these companion objects. Recently, there was like a fantastic blog post by Christoph, who goes by an amazing handle, by the way, called Blade Coder. Very cool nickname. In this, he talks about exploring Kotlin's hidden costs. It's a really in-depth blog post and an article, and I won't even try to repeat like all of that information because talking about code in a podcast is hard enough, but he dives into actual bytecode and he talks about the differences there. So again, I'll drop the link in the show notes and make sure you read through that because it's actually like a fun article. But my immediate takeaway from reading that article, at least in the early days, was, whoa, this companion object thing can actually be pretty expensive. I mean, especially in Android land. So I really wanted to understand what companion objects and objects were and what they mean for the land of static-ness, so to speak. Again, I encourage you to read the article, but it's kind of dense and it's filled with a lot of information. Instead, what I'll try to do here is explain my learnings given the context of that static usage, right? I'll just what I grokked from all of that. I also actually reference another very good article from Igor Andrivici. Sorry if I got your name wrong, but he also wrote a very good blog post, and this is at specifically looking at just constants. So the post is, where should I keep my constants in Kotlin? Again, it'll be in the show notes. The concepts that I grokked from these two blog posts almost serve like a kind of recap of all the things that we have talked about how these companion objects are created, like what it means for static usage and all of those. I put this regular val inside a companion object. The first thing that happens is, obviously, because there's only a single instance created, it functions as a static variable. That is good. But almost always, if you put a regular val inside a companion object, this is a big problem. Why? Well, when you actually look at the compiled down code, you'll see what we have to jump through. We have to jump through a whole bunch of hoops and methods to actually access that variable or that value. The easiest way, honestly, in my opinion, to find out if you're jumping through these hoops is if you actually try to access this companion object val inside a Java class. So basically, you have this companion object in Kotlin. Try to access that from a Java class. And immediately you'll start to see the problem. And this is actually kind of tricky because if you access it from another Kotlin class, everything looks nice and dandy, right? You won't even notice that you're actually jumping through these hoops. And let's maybe take an example to sort of trace that out. So say I have a class foo, right? Foo class. Inside it is the companion object, and I have a regular val. Actually, let's make it a variable, right? And I'll call it my variable, right? When I access this from another Kotlin class or a file, I would basically just say foo, which is the parent class name, dot my variable. And it looks awesome. It looks like it looks exactly like a static definition as it is, because it is like a static definition. However, take the same thing and try to access it inside a Java class, and you'll notice it looks kind of nasty. You have to do it as foo, which is the parent class, dot companion. Now again, companion is actually the name of the instance of the companion object, right? Remember when I said object automatically creates, it defines a class and creates an instance. So the compiled down class has actually created another class instance called companion for that companion object in the parent class foo, right? Again, I know this might seem a little overwhelming, but stay with me, right? In fact, just open up your IDE and try to access the companion object in a Java class, and it'll be even more clear. So you have foo.companion, and this is where it gets even more nasty. In order to just access that my variable, you can't do dot my variable. You actually have to call dot get my variable, right? So you don't have direct access to the variable, but in fact have to call a getter method, which again internally calls that variable. So let's unpack that, right? Foo, because it's the class name, that's why you have the foo dot. you have a companion, and this is the name of the object, again in quotes, we have created inside the Kotlin class. And then we don't even have direct access after the companion to the my variable, but in fact have to call like a getter method in that companion instance class in order to finally gain access to that variable, right? Again, like if you go back to the article by Igor, like he actually very nicely puts it down in code snippets, right? But the TLDR is adding a regular val inside a companion object introduces an additional object and a method, which is totally wasteful for just a single static constant, right? I mean, just imagine if you had a static int or a static string, all you want is just like a direct access to that thing, right? Like it's super wasteful to have like a new class generated for this and then have like a getter method on top of that. So how can we mitigate this? Well, there are basically two ways. One is using the const keyword in Kotlin, which stands for constant. And the other is actually using an annotation, an interop annotation called JVM field. So let's talk about these two approaches. First is when you just add the keyword const, right? So instead of using a regular val, basically what you want to be doing is tack on the keyword const before that. So const val my variable, right? So I have a companion object. Instead of just val my variable, I'm now saying const val my variable. The beauty of this is that, additional method that I talked about, like the dot get my variable, that is eliminated. So again, now having added the const keyword, if you want to understand what the cost is, what did I say you should do? Go back to a Java class and try to access this, right? Now when you try to access it, after having added the const keyword, you don't do foo.companion.getMyVariable. Instead, what you do is just foo.myVariable. So you see, this basically resembles what we originally intended to, like in Java land, right? Like if I wanted a regular constant, this is basically what you need to be doing, right? So assuming you can't do a package level member for the reasons discussed before, and you need to use a companion object, the second rule of thumb is always prefer using the const keyword. So this is great. There's just one problem again. The const keyword can only be applied to Kotlin primitives, which means I can only add it to either int and like the primitive values, or I can actually even apply it to a string. So it's only string and primitives that I can use const, which is kind of a bummer, right? Because what do you do if you need a companion object and it's non-primitive? Like if you have like your own custom class that you want to be defined in a static fashion. So I have a companion object and we have a non-primitive, right? What do I do in this case? Well, to help avoid that additional method, what you can do now is use the interop annotation. So that's the second approach that I talked about, right? You use the JVM field annotation. If it's a field, obviously, if it's like a val or a variable. And if it's a method, then you use JVM static, right? So this is the second approach to use if you need to use a companion object and you need this thing to be like truly static, right? So if you can't use const, use JVM field. Again, the best way to see if there's like an additional cost incurred, or you want to see if like your method that you suspect is being generated is removed, try to access this from a Java class, and you'll see it's exactly the same as const, right? So instead of the ugly foo.companion.get my method or get my field, instead what would happen is it would just be foo.my field or foo.my instance or whatever you name it. Okay, so then if you were me, you would ask the question, why not always just use JVM field, right? Like, why even have this complication of having two ways of doing this, right? Like, if const is only for primitives, why not just always use JVM field, right? Why do we have these two ways? Again, there's a subtle distinction here, right? The beauty with using const in Kotlin is that it's actually inlined by the compiler, right? When you use the JVM field or like the JVM static annotation, it's not inlined by the compiler. What does inlined mean? Well, if I had a string constant, say, called hello, right? Then at the call site, the actual place where I'm consuming this API and I'm calling that constant, there won't be a reference again outside to the actual value, but rather the compiler is sort of smart enough to understand that, hey, this is just like a stupid primitive value. Instead of creating another method call and then like pointing that to a reference or like, doing any of that stuff. The compiler is intelligent to simply replace that with the actual primitive value. So that's basically what we call inlining, right? And this is really good for performance, especially if you have it being called like a whole bunch of times, like numerous times, right? Now you may, again ask me, hey, Kaushik, is this like micro optimization? Like, as an Android developer, is this ever something I really need to be worried about? The answer again is it depends, right? For example, if you consider a view's on draw or on measure method, there absolutely will be like some performance implication, right? If you use a regular val inside the companion object, I can almost say for certain, like you're taking a mild performance hit, right? Now, if you mark that field as a JVM field, it's definitely much, much better because you don't have those additional method calls. But it would be actually even better if you could somehow mark it as const, right? Because then it actually gets inlined, and then that's like the optimum performance gain that you can ever expect, right? So that's basically like the hierarchy of thinking. Okay, so far I've only talked about the performance implications of the members you declare sort of inside the companion object. But if you read a Blade Coder's post, again, such a cool nickname. If you read his post on like Kotlin's hidden costs, there's also actually an insidious cost to pay if you're accessing a value that's outside of the companion object, right? So far I've only been talking about like inside the performance costs inside the companion object. But if you try to access a regular private val that's outside of your companion object, but you try to access it inside the companion object, again, like, if you read his post, you'll see that there's a huge cost to be paid. Again, I don't want to go too much into the details because it's kind of hard to explain it. But if you read that article, it'll become immediately clear. So like these techniques that I'm recommending doesn't necessarily apply to just inside the companion object. It also applies to like, just your generic use inside any class. So we have picked up a lot of these concepts in this episode. I want to end by giving you a sort of workflow plan, of sorts that I've used whenever I need to create something static or like, my Java brain is trying to think of creating a constant and I'm working with Kotlin, right? This is the rule of thumb that I kind of follow. If I need a static member, either a constant or a static method that needs to be accessed from outside of a class, then basically what I try to do is always see if I can use a package level member. If yes, definitely go with that, right? If no, and when are the two times that I really can't do that? Well, namespace conflict and, factory methods. If those are the two cases, at least the most predominant cases where a package level function will not cut it out, what I would do then, instead of using the package level member or function, I would move it to a companion object. Again, if using a companion object first, what is like the first thing you need to be doing? Use a const, right? If you can use a const, if it applies to like the approach that you're using, like a string or a primitive, please do that. If you cannot do that, that is if you have a non-primitive, then you think about slapping on the interop annotation. There are two, JVM field or JVM static, and they respectively apply to fields or methods. All right, I hope you found all of that useful. Let me know if there are any other follow-up items to this episode, or if you think you heard something that wasn't necessarily right, or if you just want to hear more kinds of these episodes, right? And we'll try to cover all of those topics. I'm learning this as well, so feel free to totally let me know if you have a better understanding of some of these things, and let's all just learn and share together. All right, thank you all for listening, and we will catch you in the next episode.
This episode of Fragmented has been brought to you by Rollbar. Rollbar is used by a bunch of companies. Kaushik uses them, I use them, but there's also folks like Heroku, Twilio, Kayak, Zendesk, Twitch. The list goes really on and on and on. If you'd like to check out Rollbar, you can go to rollbar.com/fragmented and you'll get the Bootstrap plan for free. Again, go ahead and check that out at rollbar.com/fragmented and you'll get that Bootstrap plan for free. Thanks for listening, and thanks, Rollbar.
That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.